Good morning, all. I hope the screen is visible. Okay, we will start. We were discussing about the method of section, and in the method of section, what we have seen that we should consider one section which will cut the truss into two parts in such a way that not more than three members should be intersected by this cutting plane. This is what is the requirement. Okay. Yeah. The reason is very simple that if the number of unknowns are more, then it becomes difficult for anyone to solve the numerical. So for that purpose, the cutting plane should be decided in such a manner that not more than three members should be uh, intersected by that cutting plane. Uh, See, depending on the type of numerical or the problem statement, sometimes you will come across a trust which has many members, and in that case most of you may get confused, because thing is, more the number of members, more unknowns, and then the difficulty level it increases. But for such kind of complex trusses or problem statements, you will see there is a hidden information. If you remember, we have discussed about the collinear members and a third member which is attached to that. If at the intersection point, that is when two collinear members they meet at one point, and at that very point, if third member is getting attached, and if no load is attached to that point, then you can say that the force in the third member will be zero. Okay. So what will happen because of this assumption, or because of this uh, rule, you can say, this is a derived rule based on which you can simplify the complex stress. Right? We have seen various stresses wherein the number of members were more. Just let's say example of that uh, tower, wherein you have found that the number of unknowns were more. It was a bit complex, but based on the complete structure, it was something of this sort. Okay, and few more members were something of this sort, isn't it? So over here, you only told me that these two are collinear members at this location. This third member is attached, and because of which, and since there is no force which is acting over here, this member had a zero force into it. And then, since it is zero force, then you only told me that these two are collinear members. At this location, this member is getting attached, and since there is no force involved in this member, therefore this force will also be zero. So the complete figure it got reduced to a very small picture. Okay, and the number of unknowns were less, and you were in a position to calculate the number of unknowns in that case. Let us take up one example wherein the truss structure is a bit complex. It is big, but you can certainly solve it, and using different methods. Now, since we are discussing method of joints, we will try to solve this numerical pertaining to method of joints. So let's say Okay, this is a truss structure which has got hinge and a roller support. That means definitely the reactions can be identified because there is one hinge and one roller support associated to this. Then there are few loads. These are acting in this manner. The loads are 1200 Newton, 1800 Newton, and 1200 Newton. Then this is point A, this is B, then this is C, D, this is E point, F, G, H, J. So in this numerical, you are supposed to identify the force in members BD, then CD, then DE, BE, and CH. How many unknown forces you are supposed to identify? BD, CD, DE, BE, and CH. 5. Okay. So before proceeding, just try to identify where do you obtain or where do you find these members. So these members are over here BD, this is CD, then DE and CH. Okay. So over here, it is not mentioned that you are supposed to make use of method of joint or method of section. But if it is possible for you people to identify the member force based on method of section, go for it, unless and until it is specifically mentioned. Otherwise, in the numerical, it is mentioned that you are supposed to solve it by so and so method. If it is not mentioned, then you are free to make use of any of the methods, right? But you should also take care of the time. So what we will do, we will try to identify the member forces based on method of section first of all. In that you will find that these member forces, that is force in member CD, that is this, force in member BE, and force in member CH. It can be identified, the forces in this member, these members can be identified, rather BE, BE, DE, and CH. This can be identified if I consider this cutting plane 1 1. Am I right? If I consider this cutting plane, this section 1 1, I am in a position to identify the forces in members BE, DE, and CH. That means these. Sorry, BE, DE, and CH. Is this okay? So out of 5, 3 can be easily found out with the help of this section. Okay. Few more things are given. The dimensions are given, which I have not mentioned. So I will write down the dimensions also. Okay, there is one more force over here as well as over here. The magnitudes are 600 Newton and 600 Newton respectively. And the dimensions are, that is from this point to this point. then from here to here. This is 6 meter, 6 meter. This is 8 meter. This is 8 meter. This is again 8 meter. It is from here to here. This is 8 meter. This is 6 meter. And remaining from here to here, this is again 6 meter. Okay. So the purpose of giving mentioning these dimensions is to find out the angle value. It is as simple as that. Okay. So this is the given information. One more thing, that is the height. You will require the height information. So this is how much it is, 3 meter, and this is 4 meter. Okay. Based on this, now you can see the truss, whatever is drawn, it is a bit complex because the number of unknowns are more, number of members are again more, and the geometry is again, it is complex. Now, if we consider this section 1-1, then we can draw the free body diagram and then try to solve the complete left hand side or right hand side portion. But before that, since we are in a position to identify the reaction forces, you find these values. So this is RCB, RCH. This is RH. Naturally, since there is no horizontal force involved, RCH will be 0. Summation of force in x direction. Summation of forces in y direction equal to 0. You please formulate the equation. I will write down the value. You please verify. 600 into 2 plus 1200 into 2 and plus 1800. Is this okay? Please check.
Yes, sir.
Then you take moment about any point. Let's say moment about point A. So if you take moment about point A, sorry, not A, C, point C. If you take moment about point C, what you will have? 600, 600, it is moving in the anti-clockwise direction, so minus 600 into 6. Then this 1200 Newton is passing through this. So no question of this force. Another force will be 1800 plus 1800 into this much distance, that is 14. And this will rotate in the clockwise direction. Then plus 1200 into how much will be this distance? 28. Then plus 600 into 28 plus 6. Okay. And minus RH into 24. Sorry, 28. Am I right? Is this fine? Just check, verify karo. So based on this, what is the RH value?
Sir, 2700.
2700 Newton. This is the RH value. And similarly, you calculate RCV. Okay, both are same? Yes, 2700 Newton. Both are positive values. Okay, so you have found out RCV, RCH. Okay, then you consider this section 1-1 and you now draw the free body diagram. So I will rub this part. Okay. Rub this portion, and what I will do is I will consider, let's say, left hand side portion. It will be convenient. First of all, to draw the free body diagram, and secondly, to identify the member forces. So what I will do, I will remove this portion. No need of this. Okay. This will be the part. And let me remove this part also. And let us say that tension forces are developed. Initially, we will consider tension force in each member. Okay? And we will extend this and this member and this member. What was that point? Point E. Right? So let's say this is force in member BE, force in member BE, force in member C, E. Sorry, what it was CH, force in member CH. Okay, this is 8-meter distance. So you are supposed to represent all the forces, necessary forces, whatever are available. And now what you can do is, step by step, you should identify the forces in all these members. So let's go by taking, let's say, if you take moment about point E, summation of moment about point E equal to sorry, 0. From that, I will get the value for CH, because you can see BE and DE, they are passing through point E. These two will get eliminated. So can you formulate the equation? What it will be? This will be FCH into 7, because this height is 4 plus 3, and it is rotating about point E in the anti-clockwise direction. Then what are the other forces involved? This RCV, which is 2700. This will rotate about point E in the clockwise direction. The distance is 1/4. Then again 1200 into 14, because this is that force. This is rotating in the anti-clockwise direction. This 600 into 14